Now we have finally arrived at normal distribution, the most important probability distribution. Before talking about the main idea of normal distribution, let me give an idea where we are and how does the whole thing work. When we talk about probability distribution, we are talking about a number of types of probability distribution. The first question, it is based on whether that is a discrete random variable or it is a continuous random variable. If it's a discrete random variable, it means that the random variable is countable. It can be counted. It's specific values, separate values, mostly integers, but it doesn't have to be integer all the time. And a continuous random variable is something that cannot be counted. It needs to be measured. Now, the first thing that we talk about is the general distribution. So the general discrete distribution. So that's the first thing. That's what we do in the S1 syllabus. It's the general discrete distribution, where we have a table, and from the PDF we find the probabilities and on and on. Similarly, in the continuous distribution, we have the general continuous distribution. The general continuous distribution is not in the S1 syllabus. This is in the S1 syllabus. This is in the S2 syllabus. Now, after that, we have the uniform distribution, the uniform discrete distribution, and here we have the uniform continuous distribution. This one is in S1, this one is in S2. Then we have another distribution called the binomial distribution. This one is in S2, and the final discrete distribution is the Poisson distribution. This is also in S2. So this is S2, this is S2, this is S2, this is S2. Now, there is one type of continuous distribution, that is the normal distribution, and that's what we are talking about. The normal distribution. So this is in S1. So when we talk about the normal distribution, we are actually talking about a continuous distribution. So we have a probability distribution that is a continuous distribution, and so far we have seen general distribution, we have seen uniform discrete distribution, and the final distribution in S1 is the normal distribution. So in S1 we have these three distributions, the general discrete distribution, the uniform discrete distribution, and the normal continuous distribution. Now the question might be that the people at the S1 syllabus, they should have started the S1 with the general distribution and the general continuous distribution. That makes more sense. Or perhaps the uniform discrete distribution and also the uniform continuous distribution, and they should have left the three distributions, Poisson distribution, binomial distribution, and the normal distribution for S2. That might have been a better idea, but I don't know why they chose they wanted normal distribution to be in S1. One reason might be because many people, they might not want to take S2, they might take something else, they might take the mechanics M1. So S1 is among the most popular subjects as the AS level, so at that level, so that's why they wanted to perhaps include normal distribution, because it is the most important distribution of any probability distribution. So that's why perhaps they wanted to include normal distribution here. So now let's talk a little bit about normal distribution. Normal distribution is something that occurs naturally everywhere in the world. So there is a theory, it's called the central limit theorem, and the central limit theorem states that according to the central limit theorem, it says that if you do something long enough, if you do an activity for long enough, chances are it is going to follow the normal distribution. So for example, if you're tossing a coin many times, and eventually it will follow a normal distribution. So this is the main idea behind the central limit theorem. So even if you're throwing a die, if you are hitting something at a particular moment, or even if you're calculating something, if you do it for a long time, or if you do it for a long number of times, so what happens, it will eventually follow the normal distribution. Now what is the normal distribution? The normal distribution usually refers to a special type of a curve. So if we take a look here, we have this, and we have a curve like this. If you notice, this looks like a bell, so that's why this is often called the bell curve. So the normal distribution is often called the bell curve. So this is the bell curve. Now if you notice, most of the things is around here in the middle. So most of the things is here around the middle, and there is a very small quantity here at the higher end, at the upper end, and there is equal quantity at the lower end. So if someone tells you, suppose you're if you're doing an activity, suppose you're trying to hit a target, most of the time it is going to be around the target. It will be very few times where you hit the target absolutely perfectly bullseye, and it will be very small amount of time where you hit so far away that it goes off the ground. So most of the things is going to be around here. For example, if someone you're asking someone to predict something. Suppose you're asking someone to predict what do they think is the amount of calories that they eat. So most of the people are going to predict around here, somewhere around the middle. There are going to be very few people who are going to say so much high calorie that it is beyond imagination, and there are going to be very few people who are going to say so low calorie that is going to be beyond it. So it follows a regular situation. So if I say, for example, a person needs 2000 calorie every day, and most of the people are going to say around that, maybe 1800, maybe 2200, maybe 1700. It will be somewhere around here. Very few people will predict that we need around 1 million calorie per day, and similarly very few people will predict that we need around 0.1 or 0.3 calorie per day. So you see, this is the idea. At the same time, if you're considering about the height of people, most of the people, if you explore, you will see that most of the people height somewhere around here. Very few people are going to be so tall, 9-8 feet, that they're around here. Very few people. And most people, there are going to be very few people who are going to be so short, 1 feet or 1.5 feet, who are going to be here. In the world, most of the people fall around here. So this concept is the bell curve, and it's the most important probability distribution. And in the bell curve, one thing is very important, that the center of the data, this one here, the mean is equal to the median is equal to the mode. So do you remember what happens if the mean and the mode and the median, the three central tendencies, when all three are equal, it means it has no skewness. It means it has zero skewness. So symmetry, it means it is symmetrical. This side and this side, it's symmetrical. That's why it looks like a bell. So it's symmetrical, so no skewness. So it means no skewness. So it's symmetrical. So no skewness means symmetrical. So whenever we are talking about this particular distribution, so we are actually talking about a distribution, a curve that has no skewness, meaning symmetrical. That means the mean, the median, and the mode, they are all equal, and the shape is such that it's the bell curve. Now at this moment, now that you know what the idea behind it is, it's a situation where most of the things occurs around here and very few things occur at the high end and very few occur at the low end. Another important thing to understand is that this curve, when we do a discrete general distribution, the probability is given by the actual PDF. So the probability is PDF. So here, if you want to find the probability, so the probability x equals to the instance x is equals to the PDF, which is the probability density distribution function. Here, for continuous distribution, the probability is not. Now I'm talking about continuous distribution generally, since this is in S2. So that's why I'm telling you how does the probability we find. Here, this particular point is fx. So if you have one value of x, suppose x equals to 1 here, for x equals to 1, f1, you will find this particular point here. But that's not the probability. The probability is actually the area under the curve. So that's why it's different. Remember, this is very, very important note. Here, the probability for a normal distribution, actually for every continuous distribution, probability is the area under the curve. So the probability is not the PDF or the probability density function is called for continuous. That is not the probability. The probability is the area under the curve. And if this is fx, if this curve is represented by fx, this actually, roughly speaking, I'm just using it loosely, it looks like a parabola. So suppose fx equals to minus x squared. This is what the Cartesian equation would be if it was like that. I'm just loosely using it. That's not the case. So in that case, we can say that the area under the curve would give us the probability. Now one thing about area is that area has to be a space. Area cannot be a line. Remember, a line does not have an area. A rectangle or a square or a trapezium, these things can have an area. So remember, if you wanted to find the probability of something equal to something for general discrete distribution, that is absolutely fine, no problem. But for normal distribution, since it's a continuous distribution, you cannot have the area of a line. If someone wants to find the probability of x is equals to 1, the probability will be 0, because x equals to 1 is like a line. X equals to 1, it's a line. If this is 1, it's a line, and a line cannot have area. Area by definition is called as the flat space occupied by anything. If something is flat and the space occupied by a flat object, like the space of a floor, that's called area. Volume is the space occupied by a solid object, like a pencil box. That's a solid. The space it occupies, that's called a volume. So we're talking about area. Area is the space occupied by something flat. Now remember, a line is nothing flat. A line is just a line. It does not have any breadth or width. It's a line. Length, it has a length, so it does not refer to area. We cannot have area of a line. So remember, since the probability is the area under the curve, and that's why it is different, and this is not only for normal distribution, actually this is true for any type of continuous distribution. Remember, we should be doing this first, the continuous general distribution, then we should be doing the uniform distribution, then we should be doing the normal distribution. But since in S1 we directly go with normal distributions, it's important to understand for all continuous distribution, the area represents the probability. So for discrete distribution, the probability itself can be found directly from the table, but from here it is not possible, because it's the area itself that represents the probability. So I hope this is clear. So whenever you have to find the probability of something equal to something, that area is going to be 0. This is very, very important, because area is always has to be a region from one place to another place. This is very, very important. Another important thing to remember is that when we are talking about area, we actually find area using some sort of an integration. So the area of a curve, so if you want to find the area from this region to this region, suppose from this point A to this point B, then it can have an area. And in C2, this is part of C2 where we have integration to find the area. So if you want to find the area of this region, so the area can be found, so the probability from X to B is the same as the area from A to B of fx. Fx is the PDF, probability density function. So this is the probability, so and it always has to be in terms of a range. So this is very, very important, and the area is found by integration. Of course, we do not have to do an integration. We have a table that is given at the exam. It's called the normal distribution table, and in that table every single probability will be given. So no calculus is included in the S1 syllabus, so you don't have to actually find this probability by that, but it's interesting to know how the whole thing is working. So the area is actually found by integration. Now this is something that you don't need to know, you don't have that, but if you really want to see what the PDF, meaning the way the probability is found, not probability, the way the point on the curve is found, because in discrete probability distribution, the probability itself equals to the PDF, probability distribution function, but here it is just a point on the curve. So if you really want to know what does the PDF or the formula for the probability density function look like, it looks something absolutely terrible, something extremely ugly. But if you want to see that anyway, let me show that to you what it looks like. So this is what the PDF, the probability density function for the normal distribution look like. So PDF for normal distribution, so it looks like fx equals to, let me tell you before, this is extremely horrible, so don't worry about it, just we don't have this in the syllabus. This is what it looks like: sigma square root of 2 pi, e is the exponential function, to the power minus x minus mu whole squared divided by 2 sigma squared. Now think about it, this even is not the probability. For continuous distribution, the probability is given by, suppose you have to find the probability of something A to B, that probability is given by an integration, area under the curve, A to B of the PDF. Imagine integrating this thing. It is extremely difficult, that's why it's not in the syllabus, it's not even in your university, you don't have to do this. A table will be provided. In that table all the probability, meaning all the area under the curve, will be given. So you have to remember, whenever you do a probability continuous distribution, it has to be done from a basic rule. You don't have to go through the complex process. Okay, let's get back. Now one more thing that needs to be remembered is this is continuous. You have to remember, it is not discrete, it doesn't have separate values, it is continuous, meaning it cannot be counted, it is measurable. So if I say discrete, less than 3 can mean 2 or 1 or 0. If I say continuous, less than 3 can mean 2.99999, something very close to 3. So random variable here is continuous. For that reason, probability of x is less than or equals to a is the same as probability of x is less than a. Here there is no difference. If it was discrete, that's a big deal, but here no problem at all. All you have to do is remember that this is continuous, makes no difference at all. One more thing to remember about here is the symmetrical rule. It is symmetrical. That means one side and the other side is completely identical. So when something is symmetrical, we can take advantage of that situation. We'll use this. So at the moment, the important thing to remember is the normal distribution is something that is found universally. Everything follows the normal distribution. That is called the central limit theorem. If something can be done a large number of times, we can actually find that it resembling a normal distribution. A normal distribution looks like a bell curve. We call it bell curve because the curve looks like a bell, and it is mean, mode, median. All the data has to be equal, so it's a symmetric. It has no skewness. And remember, for a normal distribution, we cannot have this situation where probability of x is equals to something. Since it's the area under the curve, area for that would be 0. You have to remember. So area for any particular line is 0. A line has no area. It has to be a region, either less than that or more than that. This is very, very important. So let's move on.